My name is Jaroslav Tulach, and I work on NetBeans. And today, I don't want to talk about NetBeans, but about a feature which is part of Java since JDK 6. And I think it's very powerful and not well known. It's a way how to enhance your compiler. Basically, I believe that it can do miracles. It can improve APIs. It can ease usability of your APIs if you create one. So I will start with a general motivation describing why I'm going to design a specific example or evolve a sample today. Then we will do I will show you a lot of code snippets, and hopefully we will also have time for some questions and hopefully answers. Okay, so I work on NetBeans IDE, which is a modular system. And in modular systems, one issue that you always have to deal with is registration of certain functionality. If you have support for Java editing, C++ editing, PHP editing, the individual modules that provide this functionality need to somehow register. So the infrastructure knows that these subsystems are available and can invoke them at the right time. The classical way how to do a registration is to have a static method in your class, which is called register provider, for example, which the modules can call at the startup of the application. Well, this is how we did registration in NetBeans 10 years ago, and it has its issues, so we are not using that anymore. The first problem is that programmers are really keen on registering, but they forget to unregister. So if you turn a module on, turn it off, well, the registration still stays there. So this kind of asymmetry creates a problem. The other thing is, and we faced that many times, inside of the NetBeans IDE, we have support for various technologies, and every programmer who is working on certain technology, for example, UML, thinks, well, this is the best feature. It has to always be enabled. So at the beginning, on start of the application, it just invokes a lot of registrations, creates registers everywhere, does a lot of initialization code. And at the end, we find out that only 5% of users are using UML. So what's the point of registering something? So much better thing than to register something programmatically is to use some declarative registration, because just invoking foreign code means that the code will do something nasty to your system. So it's much better to not call the UML code or PHP code until it is really needed. So what we can do with that? We need to create scalable registration. We need to have a way how to basically declare that you want to register some provider. And since JDK 6, there is a class in Java util package called service loader, which is basically used for this purpose. You can ask the service loader to load implementation of certain interface. I guess it's, yeah, this is the example here. And what the service loader implementation does is that it goes through the class path and looks for text files stored in metainf/services/name of the interface you are looking for files, and reads their content. And inside of such file, there should be name of the implementation class. Then the service loader instantiates these classes, and you can use them. So it's basically a way how to do some kind of component injection, but compared to Spring and other dependency injection frameworks, you don't need to do all the wiring at the beginning. Basically, until you need implementation of certain interface, nothing happens, and only when you call the service loader load, it will iterate through all the implementations. Well, the only problem with that is that if you are seeking for one particular implementation of the interface, you still need to load them all and then somehow select the right one. And that's not scalable either. So I think it's time to switch to first demo. So one of the problems that we needed to solve in NetBeans platform, and I know that this is a problem that almost every runtime container needs to solve, OSGI solves the same issue, is the fact that Java allows you to register a URL handler factory for processing your own or providing your own handling of different URL protocols. The problem is that there can be only one factory. And in modular system, well, every module can basically may have a need to provide their own implementation. So we somehow need to create one generic proxy handle factory and then delegate to the appropriate implementation. So this is what I'm trying to do here. So first of all, I created a class URLs, which registers itself into the as the stream handle factory, and it registers a global proxy factory. So what the proxy, the important method which needs to be implemented is create URL stream handler. And here is the implementation which uses the service loader to seek for available implementations. The font, make the font bigger. Oh, let's try it. Oh, actually, this? No. This? Neither. That's better? Okay. So here is the usage of service loader, and I'm asking for all implementation of URL stream handle factory. And then I'm delegating to their method, create URL stream handler, and I'm waiting for the first one which creates a handler for given protocol. So how to use that? I guess test geek protocol. So this is a test that shows we can support geek out protocol. And the implementation of this protocol is here. So basically, I create implementation of URL stream handle factory. And well, one thing that I would like to demonstrate today is that there is a lot of boilerplate code. So basically, I need basically, I need 3 classes to implement the functionality. I need the URL stream handle factory. I need to implement a geek out URL stream handler, which basically just instantiates the URL connection. And then the only important functionality is here. That's the URL connection, which really creates the input stream, which people can use when using the protocol, as demonstrated here. OK, and the next thing is the registration. If you want to register yourself into the service loader system, you need to create a special meta services file. Here is it. The name follows the name of the interface we are searching for. And inside of it, you need to properly type the right name of your class, fully qualified name. And, well, this is too fragile, because I've seen many cases when people make a typo there. So the first thing, we would like to eliminate this and somehow make the system more robust by using annotations. So let me switch to a slightly better version of the same sample. And I'm going to introduce the first annotation. It's compile time annotation, and it's provided by one NetBeans library, but it can be used in any Java application. It's NetBeans independent. So gig high. So this is it. So this is a service provider annotation. And basically what it does is it will generate the meta-inf services file for you. So if I recompile and run the test, we can look at the generated classes, and inside of meta-inf services, we can see that right now there are two classes, two implementations mentioned. And the first one is there registered manually, and the second one is basically generated by the compiler. And this is really good thing because it basically prevents typos. The name of the fully qualified name of the class, which is in meta-inf services file, is basically derived by compiler, and the compiler will not do any mistakes. So this is our first introduction to compile time annotations. And let me now talk about DSLs. So basically what we are doing here is trying to create a special language to express registrations. And special languages are called domain-specific languages. Here is Wikipedia definition. And I had a talk about DSLs together with Rich Unger 2 years ago. And actually, the Wikipedia definition was not good enough. So we needed to somehow create a classification, what a DSL is. And so we can basically talk to each other, so we can have the same vocabulary. So the first classification is about processing style. If you have DSL, you can basically create your own parser, read the file, and somehow interpret it. So that's external DSL. What you can also do is to store DSL or encode the language inside of XML document. And the third processing style is that you embed the DSL language inside of other language. And that's basically my favorite one, and I will talk about it today. Then Rich claimed that DSLs can basically be any general purpose language, even Turing complete, so you can basically express any form of computation. For me, I rather think about DSLs as declarative languages, that you declare something and something magically happens for you. And the third way how to differentiate between DSLs is tooling. Basically, if you create your own new language, then you need to enhance every IDE to recognize it, to provide syntax coloring, to provide code completion, to somehow show the structure of the elements inside of your language. And that's a bit of work. On the other hand, there are DSLs where the tooling is standardized for all IDEs. And that's basically what I will demonstrate today. So here are a few DSL examples. I think SQL is a perfect language, and it's declarative. It's an example of domain-specific language. PostScript. Apex is basically the Turing complete language written by Salesforce, where Rich is employed. So, and then there can be a lot of XML variants like AND or voice XML, XSLT, and also embedded and internal languages that you somehow put inside of usually functional languages like Haskell or even Scala or Ruby. So first thing I'd like to touch is whether it's good to embed your domain-specific language into an XML file. It's not. On the right side, you can see an example of voice XML written, which is a domain-specific language for describing conversations and voice processing. On the left side, you see the same language, but written without XML. So, why would any user try to type the XML thing when it's 4 times longer and does the same thing? So, for XML, you are basically simplifying your own life because you will get the parsing for free. But for users, that's really bad choice because you are complicating what they how they can use your language. Here is a small example of how we used XML in NetBeans. So we were young, and we did a mistake of allowing registration through XML files. And I cannot count the number of cases when people make a typo in these registrations. So right now, we are moving away from these XML registrations and trying to replace that with compile time annotations. Another topic to touch is the embedded DSL. Whether compared to the XML stuff, embedded DSLs may not be that bad. The example on the right top corner is basically Backus-Naur form or describing expressions in almost any language. And when you compare it to the bottom sample, which is written in Scala, it's not that different. Basically, it can be, it has one-to-one mapping. And moreover, not only that you get parsing for free, but you also get interpretation for free. So not only you define what how to parse the language, but here you can see that it also knows that plus means to sum two numbers, and multiplication means to multiply two numbers. So embedded DSLs are not that bad, I think. Just, well, I'd like to use embedded DSLs inside of Java. And, well, Java is not that flexible as Scala that allows you to hook in different operators and change basically the complete semantic of the language. So the question is how we could use Java to be a good language for domain-specific, embedded domain-specific languages. And the answer is annotation processors and basically hooking up into the Java compiler. So let's see how we can rewrite our example with the URL registrations to be more scalable using compile time annotation processors. Check out revision. Annotation. Okay. So the first thing to do when you want to create your own annotation processor, you need to create annotation. So here is the example. And make the font bigger. Okay. The thing that I like to point out is the retention policy. Basically, this annotation is available only in source file. And as soon as a class file is generated, it's going to be discarded. That basically means you cannot do any processing during runtime. The processing needs to happen during compile time. And to achieve that, we need to create annotation processor. But first of all, let me show you the usage of the annotation. So basically, we still have our old code, URL stream handle factory, but instead of registering using the service provider annotation, we register using the new annotation and specify the protocol. What we will do is basically modify our generic global proxy factory to seek in protocols. And instead of reading meta-inf, I need to scroll it. Instead of reading the meta-inf services using the service loader, we will read some files which are generated in our location and encode the name of the protocol. This will basically guarantee that as soon as someone is using certain protocol, we will load the right implementation and no other one. So now the question is how this file is going to be generated. And for that, we need the annotation processor, which is here. And So first thing, when you write your annotation processor, you need to register it. So JavaC will find it. Again, the registration or the JavaC is using service loader to find all annotation processors. And so you need to register it by creating MetaIn services file. Oh, yeah, I'm sorry. Is it possible to change the size of the font? Yeah, I don't know. Formatting. Fonts and colors, thank you. Monospace 14. All languages. So 24? No. 18? Yeah, I think it should be better. So the JavaC compiler will read the MetaIn services and find all registered annotation processors. I'm doing the registration using our annotation that generates the file. Then you need to specify the fully qualified name of the annotation you want to process, which is done here. And then the only missing piece is basically the process method. So during compilation, JavaC will, if it finds the annotation you are interested in, it will call you this method. And here what you can do is to find all elements inside of the compiled code which are annotated with this annotation. You can get the annotation, ask for values that are in the annotation so we can get the protocol, and then basically we can create the file and write the fully qualified name of our of the element, which is computed here on this line. We can write the fully qualified name in there. So that's it. Basically, it's not complicated. Writing annotation processors is relatively trivial. So what we achieved? We defined our domain-specific language with a special way to register URL protocols. We made it scalable, so we load only the important, only the implementation which we really need. And we prevented typos by generating the files, the supporting files by the annotation processor. We basically eliminate a lot of errors. Still, some errors can happen. So, for example, what we need is we need to be sure that the class that is annotated by the protocol is public and has a public constructor. So because the service loader won't instantiate classes which are not public and don't have public constructor. So let's switch to another version. Constructor check. Okay. Is it? Okay, here is it. So basically, what you can do, you can inspect the elements that your annotations are attached to. So I can basically ask for modifiers of my class and verify if it's public or not. And if it's not, I can generate an error. And the error will be basically reported by the JavaC. So let's try it. I will remove the public keyword here and try to compile it. Okay, and here is basically the error generated by our annotation processor. And it looks like a classical error created by JavaC, and it's emitted during compilation. So by doing this, you can basically prevent or detect mistakes early and even tell users what's wrong. Instead of throwing exception during runtime, you can basically give them instructions. So right now, I fix the class, and if I compile it again, it compiles, and the tests are executed. Okay. So the JSR 269 basically specifies a model and gives you access to classes, packages, methods, and fields. You don't have access to the actual body of methods, to the code. So that's beyond the scope of this JSR. But still, even by inspecting the structure of your sources, you can do a lot of things. Simplify source code. So the thing that we did so far is detecting errors and having a scalable registration. But if we look back at the class, I will do code faults, expand all. So basically, the only important line is specification of the protocol and the way how we create the input stream. So we need 3 lines, or the user wants to write 3 lines of code, and instead of that, we have 80. So I will now try to show you how annotation processors can simplify this code. Okay, so let's switch to another version. URL connection. Yeah, that's okay. So, ciao. Okay, so this is the improved version, which basically eliminates the 2 classes which we had there previously. So instead of implementing URL stream handler factory and URL handler, we just implement the connection, URL connection. And we register this connection using the same annotation. And what we just needed to do is to improve the global proxy factory to find out, search in protocols, whether the instance is of type URL stream handle factory or if it's the URL connection. And if it's the connection, then we create the handler, a generic handler for the user, which just uses the reflection to instantiate your implementation of URL connection. Please notice that we are basically using a constructor which has 1 URL argument. And again, we should warn the user that we need a constructor with URL argument. And that again can be done inside of the processor. Well, I would hope so. So here is the detection. So basically, right now, I'm inside of the processor. I can get a representation of URL stream handle factory class and URL connection class as a type, and then I can ask whether my element is basically assignable into this class or into the other class, and based on that, I can generate something different. Okay, so that's the check is not. Okay. So right now, we managed to simplify the code a bit. The next level when writing annotation processors is not to just generate some resource files, but also generate a Java classes or Java source files. So the JavaC basically executes your annotation processors. And in case your processor generates some new Java class, it will rerun the compilation once again and compile the newly generated class. And you can do tricks with that. For example, you can have a class which extends a class that does not exist and will be generated by the annotation processors during the compilation. But that's not what I'm going to demonstrate right now. I should mention that basically you cannot change existing classes or existing code. You can only generate new ones. So the JSR 269 is not that flexible as transformation in Groovy or Project Lombok, for example. But still, we can do a lot of things with that. So another demo follows. Git, checkout, revision, head. So this is the final version of our code. Well, it should be. It's not. Let's try it once again. select so the most recent version. Okay, check out. So basically, this is the final simplification of the user API. So I mentioned that the user basically wants to write 3 lines of code, and well, we basically managed to achieve it. So what we did is we changed the URL protocol registration to be applicable not only to types and or classes, but also to method. So right now I can associate the annotation with a method. And the method basically takes the URL and creates the input stream, which is all that we wanted to do. So now the question is how we can register this method into the system so it's so basically it can be used by the generic proxy factory. And we know that the generic proxy factory, generic URL stream factory is basically loading classes. So what we are going to do, we are about to modify the annotation processor to basically generate a wrapper around a method. So here, as soon as I find out that the annotation is attached to a method, I will generate a class next to the class in the same package, and basically the class will extend the URL connection and then call our static method. The nice thing there is that I'm using the same annotation on the generated class as well. So in the first round, the annotation processor will generate this class, and in the subsequent round, it will recompile this class, and the annotation processor will create the registration in metainf/URLs. So now I would like to show you the code, the generated code. So, okay. Classes, test, classes, metainf services, URLs. So here is the registration that we wanted to have, and somewhere here should be the generated class. So basically, this is the Java class that was generated by the annotation processor. Code false, expand all. Yeah, so here is basically the call to the static method. So the problem with JSR 269 is that it was not designed for incremental compilation. It works really well if you do a clean build of your project. However, if you are inside of the IDE, then usually the IDE, and you change a single class, then the IDE basically reparses just the single class. And writing annotation processors that are ready for working in this incremental mode is not really easy. But it can be done. And I think we are using these compile time annotations a lot inside of NetBeans. And we were relatively inventive in generating a lot of different things. And as a result, I think the NetBeans IDE is relatively good in supporting even the incremental mode inside and giving you a sense and information about the files that are basically generated by the annotation processors. So here is an example of an annotation which we are using in NetBeans. I need to find it. Messages. And okay, here, what is it? This is it. Messages. So this is the annotation. So you probably know that when you want to do a localization, then you store you have resource bundle, and probably you have properties files next to your source code. And it's a pain in the ass to reference a key in a resource bundle and make sure that the reference from inside of the source code is always correct with the key inside of the bundle. So what we did, we decided that we want to specify the keys or specify the content of bundle properties inside of the Java source code. So we created this annotation, which basically says, OK, put this key into bundle properties file, and this is the value that you will get. And the annotation processor is basically going to generate the bundle file. But not only that, it will also generate a bundle.java file. And the bundle.java file has methods to obtain the particular keys. And if the key has a parameter, then the generated method will have the appropriate number of parameters. So what I can do right now is to modify the definition to have 2 parameters. And you can see that the IDE immediately detected that the method is not there, that I should basically provide another argument. Again, if you are interested in this annotation, it should be easily usable in any Java application. And I would like to repeat that getting this done was very tricky because basically we are generating a single bundle Java file for every class in a package. And that means if you change a single class and add new bundle keys there, the processor basically needs to update the file correctly in incremental mode, and that was not easy. OK, so that's basically the whole example with URLs that I created. And right now, I'd like to return back to the topic of DSLs. So I mentioned that 2 years ago, we had the API design versus DSL design shootout. And I was afraid I'm going to lose because writing APIs in Java cannot be as powerful as, I don't know, for example, accessing a database in Apex or, for example, in Ruby on Rails, when basically you can write a code and obtain content of your database and consume it immediately. In Java, we usually have to use Java Persistence API that will force us to define entity classes and then make sure that the structure of the entity classes is correct with the structure of database. So I said, OK, let's try to change it. Let's use annotations to give you a live view of a database. So here is a little demo. I guess I'm going to close all the classes, collapse the project, and then live-db. That's basically the example. So I should have a database running on my computer, which contains one table called age, and it has 2 fields. Name is of type string, age is a number. OK, and here is, wow, yeah, OK. Here is usage of annotation that I created. So basically it says, OK, connect to the database, perform this query, and create a class in this package called age that will represent the content of the database. And wow, OK, and here is a test which shows how this can be used. So basically, the generated class will have a query method, static query method, which returns a list of results. And then each of the result basically has a field representing a column in the database. And you can see that basically these columns or these fields have proper types. So you always know whether age is integer or string, and you can basically directly access it. So now let's try to modify the table by adding a new column. So let's add field of type Boolean. And now we should, in the code completion, we should immediately see all the free fields. And we don't, because we need to somehow tell the IDE to refresh. So what I'm going to do is to just modify this file, which uses the annotation, which basically told the IDE, now, please reparse. And if I return back to the test, now we basically see that we have that the age class has been regenerated, and now it has free fields. And there is the good field with type Boolean. Okay. So I think that this shows how powerful the annotation processing can be. I don't think that this kind of annotation should be used in production. It's just for sample purposes. And actually, when I think about annotation processors, I believe that they are the easiest way how to extend functionality of any IDE, which is JSR 269 compliant. Because not only you can hook into the compilation, but each annotation processor has a special method called getCompletions. And this method is supposed to be called by the IDE. So, okay. So first of all, because annotations are part of the Java language, you get code completion for free. You get JavaDoc, you get information about fields, and so this is basically for free. But you can also hook in and provide special completion, either static. So for example, I know that the query should be SQL select. So if I press Control space, the IDE talks to the annotation processor and asks what could be the suggested completion here. And I can also create a dynamic completion, which basically connects to the database and gives me a list of tables. So to demonstrate that, I will create a new table, column. Okay, so now there are two tables in the database. And when I press Control space, really the annotation processor connects to the database, finds out that there are two tables, and offers me completion. You should probably look at the implementation of the live DB processor. And again, it's not that complicated. So what it does, it finds, again, when you write your annotation processor, the best way to do is to copy the code from somewhere, because all of them are basically the same. You find all the elements which are annotated with your annotation, you get information from the annotation, and then we are going to create a Java file. Here we connect to the database, find information about the structure of the database, and then we generate the class header, we generate fields, and then we generate the query method. And that's basically all. And for the completions, the method is this is the method which is called by the IDE. The method is called getCompletions, and you basically get similar information to, so you know where the completion has been invoked. And based on that, you can basically either select, return completion statically, like in this case, or again connect to the database and list all the tables that are there. So if you remember the horrible example with XML layer file, we are basically trying to get rid of that and replace all its usages by annotation processors. We enhance our APIs, so they contain, so they have new annotation processors and compile time annotations, and they basically generate the layer file. So we are fully backward compatible with the original XML layer XML file structure, but our APIs are now much more usable and prevent user errors during compilation. Oh, I think we have 6 minutes. So here are a few slides about evolution of annotations. So yeah, I'm interested in API design, and so far I was basically designing just libraries. With annotation processors, it's slightly different, because the contract with the user of the API is not happening during execution. It's happening during compilation. So for example, what you can do is you can have still the same annotation and just changed the annotation processor in subsequent version of your API and generate more effective code or something else. So the user, just by recompiling, will get better behavior without changing anything. Often it happens that people need to enhance existing annotations. And that's possible because annotations have default values. So you can basically add new attributes to annotations and specify default values. So whatever used to compile before will compile again. That's one version or one way how you can extend the semantics of your annotations. The other one is to introduce new annotations and then basically annotate the same element with more annotations that provide some special meaning. Slight problem is versioning of a compiler. The JSR does not specify a way how the processor can communicate with the compiler and request some most recent version or say, okay, this is broken JavaC that I'm not going to run with. So this is slightly problematic. It would be good to have a way for annotation processors to really specify the least, the minimal version of JavaC they can run with. Annotations cannot inherit from each other. So basically, you cannot create a hierarchical structure of annotations. So rather than that, you probably need to use composition. So here is an example something that we have in NetBeans. If you want to register an action, you basically use multiple annotations, and then there is a processor which tries to process them both, all. The problem there is you somehow need a way for other modules that add new annotation to also hook into the processing class. So for that, what we are trying to use is basically annotate the annotation with meta annotation. So we know that when this annotation is present, we should also invoke some special processor class to generate something, some additional information. And that's basically all. I'd like to stress that we all need DSLs basically all the time. When you are about to choose whether to write your own parser or base your DSL on XML, then I'd like to advocate using of annotation processors because they are well integrated into the Java language. And basically, you will get tooling for free in every Java JSR 269 compatible IDE. And as we see during the example, annotation processors can basically eliminate a lot of boilerplate code, and they are joy to use. So, because the NetBeans team is very interested in compiler, in JavaC, in annotation processors, we have submitted few other sessions, tutorial, and even hands-on lab. So here is the list. I will run the hands-on lab on Thursday. And basically, we will go through the same example as we went through today. Just people will be able to code their own annotation processors. And I should also mention that I will have managed to publish a book about API paradoxes, which includes also one paradox about the live database annotation. And the book should be available by end of this week. So if you are interested in, you can get it. And that's basically all. If you have questions, it's time to ask.
So in your example with the processing app messages, it looked like you had code that was in the same file as the NetBeans annotation, referencing generated code.
Yes, yes.
So my understanding of the way the compiler runs is that it goes in rounds and will only visit the file once. If you start visiting that file, it's referencing a file that doesn't exist. How does that play out?
Okay, so the observation was that here in the, during the usage of messages annotation, where is it? Oh, here. So basically, the annotation is about, or the processor for this annotation is about to generate bundle file. So during the first round of compilation, basically the compilation of this file has to fail because the bundle is not available. So I will try to recompile it, and let's inspect the error messages. Wow. The output is surprisingly empty. So basically, I think, at least I saw it in when we used this annotation inside of NetBeans modules. Probably we have a more verbose mode for the compilation. The JavaC really emits the error in the first round, and then just starts again, and it succeeds for the second completion. Yes, yes. It retries the compilation of failed files. And it does it only if a new Java file is generated. Otherwise, it makes no sense. Another question? Oh, okay, so your question is, or you would like me to compare compile time annotations and runtime annotations. So I think one of the biggest weaknesses of runtime annotations is that you need to inspect for presence of these annotations during runtime. And that's not useful for the NetBeans IDE. Well, it may be useful for server, because start of a server is not that is not something that is done too frequently. Definitely not in production. But for the NetBeans IDE, if we had to go through 1,000 of jar files and load all their classes and on every start and try to find out where certain annotations are used, it would be really huge problem for the startup time. So with compile time annotations, we basically put the load of analyzing the presence of those annotations into the compile time, and we generate the layer XML file, which then can be read much more easily.
My question is more that how different development process of that processor for compile time processor and runtime processor.
Okay, so how different is the way to process compile time annotations and runtime annotations. So basically, if you want to access information about annotations during runtime, you are using reflection API. And then for each method, for each class, you can get instance of the annotation and do something with it. If you want to do it during compile time, then the reflection API is of no use. You need to use the JSR 269 API, which is packaged in JavaX package. Let me show the imports. So here is it. So this is basically the So these are the APIs that you need to use during when you want to hack into the compiler. Also, this API provides slightly more information, I would guess. You can, for example, access names of parameters, which during runtime they are gone. There is new JSR to make them available in the class file. So, okay. Okay, so the question is how we in NetBeans hint the user that this method or this class should be annotated with some annotation. And actually, we do it with wizards. We have the benefit of having IDE. So if you decide to create a new file somewhere, well, I probably don't have the NetBeans project here, but I can try it. New. So we have a lot of wizards, and basically it will generate the skeleton code, including all the annotations. So then it's much easier for the user to know that the annotation should be used. And also, annotations provide a nice way for two-way editing. So the wizard generates the code, but then it's hard for the wizard to regenerate the code. With annotations, this is basically much easier because users can really tweak the parameters of annotations and modify them. That's another benefit.
If you want an interface class, then you also write process to scan every class to get the file.
Yeah, that's true. You can. When you define your annotation processor, you can say that supported annotation types is a star. And in such case, this annotation processor will be invoked on every compilation, which includes your jar file on a compilation class path. And then you can basically go through all the classes and say, OK, no use of this annotation. That's a problem. You should use it, dear user. The question was whether I can create an endless compilation. I think you can, and JSR is not going to deal with that at all. It will just run forever. Another question? I use hard-coded string. Okay, so the question is whether I can recommend a templating engine instead of hard coding the code here. So in NetBeans, we use FreeMarker by default for generating templates, but not for annotation processors. Annotation processors, we just hard code all the time. So it's It's not that bad, I guess. It works relatively well.
Is there an issue that you can't have your annotation processor depend on other jars?
Issue that you cannot have annotation processor depending on other jars. Oh, so if I wanted to use FreeMarker to generate the code, then people would need to include the FreeMarker templating library on the compilation path as well, obviously. And less dependencies is probably better. So, yeah, another reason why not to use any templating engine. It depends how complicated code you generate. Usually, we are generating simple code, and often we are not generating code at all. We are usually generating the layer XML file, and actually for that we have a special subclass of annotation processor called layer generating annotation processor, which has a builder-like interface. So you don't have to deal with with generating XML. You basically use a builder. So that's probably answer to your question. I guess it's time to finish. So thank you for your attention.